Hello, everybody. You are very welcome to Clouds, Crops and Climate, a free webinar for junior cycle science and transitioner students. Today is Tuesday, the 11th of November, and we, of course, are celebrating National Science Week. My name is Emer Ferguson, and I'm just one of the Science Communication and Engagement Officers here at Teagasc, and I am joined behind the scenes by my wonderful colleagues across Met Éireann and Teagasc today. We have a fantastic lineup for you all here joining us live this morning. I know that we are joined from schools all over the country, as well as from colleagues and general members of the public who are just so fascinated by what we have to talk about today. We have everything from climatologists to meteorologists to climate scientists and everything in between. So please don't be shy. The purpose of today is to ask as many questions because let's face it, scientists love questions. So without further ado, I am going to run through just what today is going to look like. So as you can see, I've done the easy part for me, which is introducing myself. My name is Emer Ferguson, as I said, and behind the scenes, I have colleagues Maureen Egan, Gráinne Connolly, Rebecca O'Neill from Met Éireann, as well as all of our wonderful panellists who are joining us today. So how today will work, once I've done my little spiel here at the start, I will then hand over to our fantastic scientists. Today, roughly half of our talk today is going to be short presentations, no more than 5 minutes, so lots of time for you guys to listen and absorb some of the information. Each of those 5-minute presentations will have a really short video at the start, which is such a fantastic way for you to get a behind the scenes look at what it is to be a scientist in real life, albeit that we're all coming from all over the country. I don't know about you guys, but this is definitely the perfect day to talk about weather, as it is currently absolutely milling down here in North Cork. So, introducing our panelists, I'm going to ask each and every one of them to turn on their cameras as I name them out, just so you know there are some faces behind those names. So, starting with our colleagues in Met Éireann, we are joined by Aoife Keeley, we have Pádraig Flattery, we have Clara Finkela, and from Teagasc we have Elodie Ruel, Carol Richards, and as I say, we have some other people behind the scenes moderating our chat. So I'm so happy to welcome each and every one of them. So they're all going to turn off their cameras now. They're a bit camera shy this morning. And just before we start with our first speaker, I did just want to do a few call outs. I know that there is approximately 3,500 students watching behind all of the registrations. I know the teachers are hopefully doing all of the clicking and progressing and all that kind of stuff. So wherever you're coming from in the country, you are so, so welcome. Shout outs to a few that I recognise here. We have Loreto College in Foxrock are joining us. We have Rathdara joining us all the way from Dublin. We have Dunmore National School in Galway, 32 students joining us from there. We have Sacred Heart School in Westport in Mayo. And we have, I'm just going to find another one here, Wexford, Enniscorthy Community College. So you are all so, so welcome. Before we go to our first speaker, just to tell you that throughout this presentation, throughout this webinar, you are most welcome to ask questions. So the Q&A function is open as of now and will be moderated by my colleagues behind the scenes. What I'd just ask you to do is pop in the name of your school, followed by a short question. Keep it as short as possible so we can get to it. Short question, and that is it. So you can ask those questions as the presenters do their talks, but we will keep the Q&A section till the very end of today's webinar. So again, we have about 25 minutes at the very end for us all to answer all those questions. So without further ado, I'm going to hand us over to our very first speaker, which is Aoife Keeley. So Elodie, when you're ready.
Hi, my name is Aoife Keeley and I'm a meteorologist here in Met Éireann, working in the forecasting office where we monitor and communicate the weather across Ireland, our coastal waters and our airspace. Now to do this we use a lot of different tools. We use things like satellites, radars and observations from both the ground and up through the atmosphere. All of this helps us to build a picture of what the weather is doing at any given point in time and also how it's going to change in the coming days and hours. With this information, we produce forecasts and warnings to make people and organisations aware of what's on the way in the weather. Now, this is especially important in cases of severe weather, as we make people aware of the risks and help to save lives, homes, businesses and crops. But it's even important when the weather's not so severe, as we help people go about their day-to-day lives, if that's deciding what to wear or where to go. In this webinar, we're going to take a look at some of the basics of meteorology, how we produce a forecast, and why Ireland gets the weather that it does.
Thank you very much, Emer, and hello everyone. So first thing I suppose I want to start off with today is the most basic of meteorology basics, and that is what is the weather. So we can all look outside the window there today and see, yeah, absolutely, it's booking down across a lot of the country. But in a more general sense, the weather is basically just the state of the air in a given area at a given time. So by that I mean it's just how warm is it? What temperature? How much rain are we getting? Is it windy? And my job as a forecaster is to figure out how that weather is going to change in the next few days, or even sometimes just in the next couple of hours. Now, to do this, we do use observations. We have to figure out what the weather is doing right now before we can figure out how it's going to change. So, as I was saying there, we use a lot of different tools to do this. So, we use big things like satellites, which orbit around the Earth and give us a picture of clouds, to things like rainfall radar, which gives us a picture of the rain coming in across the country, and even weather stations. So, these are stations that measure the weather, things like temperature and rainfall, in a small space. So, only in one point across the country. And we use all these things to build this picture of what the weather is doing right now. We also use them to draw analysis charts. Now, these charts are the maps that you might see where we have drawn in fronts. So those blue cold fronts and the red warm fronts, we examine all these observations to place those fronts on these maps. And by doing that, we can figure out what weather we might expect in the next few days. And then, of course, all these observations are fed into complex computer models, which help us to forecast the weather in the coming days. So we examine all these computer models to figure out what is most likely to happen. Now, that can be quite difficult here in Ireland because we are at the mercy of the Atlantic. So a lot of our weather is coming off the Atlantic Ocean, and this can change quite a lot. So you can go from a really wet day to a really bright day very quickly here in Ireland. And though it does bring us quite a lot of unsettled weather, it's also why our weather is kind of in this Goldilocks zone. So we tend not to get weather that is too hot or too cold, or even weather that is too wet or too dry, even though sometimes it does feel like it's too wet here. But it generally keeps our weather just kind of nice, steady, and mild. However, the Atlantic does also tend to bring us most of our extremes. So, low pressure systems that we get here in Ireland, like the one that's bringing the rain today, do tend to come off the Atlantic. Now, these generally just bring the usual unsettled weather, some rain, some drizzle, and maybe some mild temperatures. However, every now and again, we do get storms. So, storms are low pressure systems that develop over the relatively warm waters of the Atlantic, and they get so strong thanks to these warm waters that they can bring us very strong winds and heavy rain as well. And as well as the Atlantic, we also have the jet stream, which you might have heard of. And this, by nature of us being kind of on the edge of Europe and at the right latitude, this jet stream often moves across the country and it acts like a kind of storm motorway, driving all these storms across Ireland. Now, that does mean that every now and again we get impactful weather. These storms can, of course, cause flooding and cause kind of dangerous weather near coasts, but as well, they can have an impact on things like agriculture. So they can damage structures like sheds and so on, and they can also cause damage to crops and livestock as well. So this is why we name storms, is in order to raise awareness around these dangerous weather events so that people are more prepared for them. But as I said there as well, it's not just storms that we focus on. We're also focusing on the day-to-day weather. So like today, even though it's quite wet across the lot of the country, most people won't see an impact from the weather other than whether they have to wear a coat or bring an umbrella out with them this morning. And that's kind of our job. It's focusing on not only the really extreme, dangerous weather events, but also the things that will affect people just once they walk out the door. But that's it for me. So I'll hand this back to Emer now, I think.
Fantastic. What an opener. Thanks so much, Aoife. No, I'm fascinated by the naming of storms in particular. So yeah, really, really cool stuff. So great start. Thanks so much, Aoife. So again, I invite our participants now. I can see there's loads of you coming in now to add your questions. So again, you have a little brief moment in your classroom, in your hall, just to throw out that question and relay it back to the person who's in charge of your computer. So if there's any questions, remember to put down the name of your school, followed by your short question, and if there is a particular person that you'd like to direct that question to. But as we're waiting for those questions to come in, I'm going to hand over to our next speaker. So Porrick, over to you.
My name is Porrick Flattery and I'm a climatologist at Met Éireann. While weather and climate are very closely linked, it's important to understand the difference between the two, where weather is the conditions we experience in a particular place for a short time, and climate is the average weather conditions over a much longer period, usually over 30 years. As a climatologist working in Met Éireann, I'm involved in monitoring and analysing information and readings from our network of weather stations all around the country, and comparing that information with previous figures to see how things have changed. From analysing these changes and trends, we can then produce graphs and reports to show how climate is expected to change up to the year 2100. Within these reports, it's projected that Ireland's climate will become warmer and wetter, and this will lead to a longer growing season as minimum temperatures will not be as cold as they used to be. Now, this might sound like a good thing, but the wetter weather also means that animals may not be able to graze the land, crops may not be able to be planted and harvested, and there's a higher risk of pests spreading from Europe and thriving in these warmer conditions. So during this webinar, I'm going to talk more about how Ireland's climate has changed and how it's expected to change in the future. Okay, so hello everybody. So yes, as I mentioned there, I'm Porrick Flattery from Met Éireann and I work on climate and climate change. So Aoife has done a great job there telling us about the weather. And I'm going to talk about climate, which is the long-term average of weather. And I want to start by getting you to take a look at this graph that's on your screen. And what this graph shows on the left-hand side is the year 1900, and it goes all the way to the right-hand side, which is the year 2025. And it shows the change in temperature over the past 125 years. So the blue years the blue bars that you see are years that are colder than average, and the red bars are warmer than average. And it shows us that Irish temperatures have steadily been increasing since the year 1900. So I want you to take a look at the graph and see if you can find the year that you were born, or maybe when your parents were born or your grandparents were born, and how much warmer and colder it was at the time. So for example, if you were born around 2007, you'd be in one of the red bars, you'd be above average. But if anyone out there was born in 2010, you'd be much colder than average, because 2010 was one of our coldest years in recent years. But then, as you can see, the trend is going upwards. 2023 was our warmest year on record. And this year so far in 2025, we've already seen our warmest spring on record and our warmest summer on record. So while this temperature increase that we can see in this graph might not seem like a lot, it's actually the highest global temperature that we've had in thousands of years. And greenhouse gases and carbon dioxide levels are higher than they've been in hundreds of thousands of years. So if we can go to the next slide, I'll show you how we know about this. So what you can see here is a load of text in an old book, but this is a weather record from Mark Reid Castle in County Sligo, and it's from July 1922. And this is how we know about how climate and how weather has changed over time, because we have all of these paper records that go back hundreds of years. So somebody in 1922 recorded the temperature, the pressure, the humidity, the wind, and the visibility for each day of each month of each year. And we can use these records to see how climate has changed, and you can actually help us to digitize them. So we have a load of these weather records in boxes. And if you see the web address at the bottom of your screen there, it says irishweatherrescue.ie. You can go there as part of your class or just on your own, and you can help us to turn these paper records into digital data that we can use. And the next slide, please. Okay, so earlier I mentioned carbon dioxide. So this graph here shows carbon dioxide levels from 1960s up until today. And carbon dioxide is a gas in the atmosphere that contributes to global warming and climate change. And this is from a volcano in Hawaii, and where they've been measuring carbon dioxide for a long time. And you can clearly see this increase in carbon dioxide, which has happened over these years. And this is causing climate change, and it's contributing to warmer temperatures and changes in our weather. So we've seen the warmer temperatures. On the next slide now, we'll see the changes in our rainfall patterns. So these are maps here of Ireland. And as you can see in these maps, they show the 4 different seasons, and they show how rainfall has changed in all the different seasons. So if you look at the blue bits of the map, this means it's gotten wetter. And if you look at the red bits of the map, it's gotten drier. So try and see if you can point out where your school is on the map. And you can see that in spring, we've seen decreases in rainfall in the east and increases in rainfall in the west and northwest. Then in summer, rainfall has increased everywhere. That whole map is blue, so we know that rainfall has gone up everywhere. In autumn, we can see that the west of Ireland and the northwest has gotten drier, while the south and the southeast has gotten wetter. And then it's the opposite in winter. We can see that the west and northwest in winter have gotten much wetter, while the east and the southeast have gotten much drier. So this change in rainfall patterns mean that farmers and other people who depend on the weather to do their jobs, they can't really rely on the weather as much as they used to have, or as much as they used to have been able to. So the weather patterns are becoming more predictable or more unpredictable over time because of climate change. And this means there's changes in how they can do their job day to day. If we go to the next slide, we can see what the future of climate change might look like. So this shows in the black line on the left, it goes from 1900 up until now, and it shows the global or the Irish temperature change from 1900 up until now as the black line. And then these colored lines show us the potential change into the future. So this all depends on the amount of action that governments and people take today to combat climate change. So the green and the blue lines mean we would stop burning fossil fuels and we'd start removing carbon from the air. The yellow line is a more medium range path, which means we don't take enough action. And the red and dark red lines are the worst case scenarios where we keep burning all the fossil fuels and we don't take action on climate change. And these would have severe consequences for agriculture and for other aspects of life in Ireland. And if we go on to the next slide, I'll finally just talk briefly about the growing season. So this is the amount of days of the year that we can get out and grow crops, and the crops will grow and grass will grow. So these three maps show differences in the growing season or changes in the growing season as Ireland gets warmer. So on the left, we can see Ireland at 1.5 degrees of warming, which is kind of close to where we are now. And the green colors mean more days of a growing season each year. The darker the green, the more days that we'll get in a growing season. In the middle, we can see a warmer world means an even longer growing season. And then on the right, we can see that the warmer world again will see an even longer growing season, as we won't be getting as cold in winter and will be warmer in spring as well. So that might sound good. Oh, great, we're going to have a longer growing season. Crops will grow for longer. This is a good thing. But actually, the warmer climate also means more extreme weather will happen. We'll have more extreme rainfall events, droughts, and floods. And this means while things might be growing on the land, it might be very difficult to harvest crops or let animals graze the land, as the soil might be too wet to get machinery onto it or to get cattle out onto it. So what can look like a good thing with a warmer world actually has a lot of negative things associated with it. And the next presentation is going to talk more about how weather and climate affect agriculture.
Brilliant. Thanks so much, Pádraig. That is just another fantastic presentation and definitely giving us even more context when it comes to the differences between weather, climate, and everything in between. As Pádraig very nicely did there, just getting us all to refresh our geography and see where everybody is tuning in from today. As we're getting ready for our next presenter, I just want to give a huge shout out to Killarney Community College Transitioner Group, who have very kindly popped into the Q&A there to say that they're tuning in. So please do feel free, type in where you're coming from. It's lovely for us to know where and who is joining us today. So on to our next speaker. So over to you, Clara.
My name is Clara Finkele. I'm the agricultural meteorologist in the Research and Application Division within Met Éireann. We provide and develop services for agriculture. These include a blight risk analysis. We provide data and forecasts for the grass growth model, as well as we work quite closely with the Department of Agriculture, Food and Marine on animal diseases and also on the fire danger. We also run a dispersion model, and this is dispersion of pollen, dust, volcanic ash, also diseases such as foot and mouth disease or little vectors. These are midgets that may carry disease. As the agricultural meteorologist, I also chair the AgMet group, and we are working on a project to implement an observation network to measure soil moisture, because although Met Éireann measures soil temperature, we do not measure soil moisture as yet. In the webinar, I will be talking about the science behind some of these models and what the significance there is to them. So good morning. So yeah, it's quite a disperse aspects that I'll be talking about. So I develop decision support systems that help agriculture and forestry in general. So if we start with the animal and plant diseases, so there is animal diseases that I do a weather report for the Department of Agriculture, Food and Marine in the spring for nematodirus. So this is the lambing season, and that's really to do with the temperature in March. That affects the worms that animals which graze on the land might ingest, and then they get dosed so they get protected. And in the autumn it's the liver fluke, and we just released the report, the weather report for liver fluke, and that's to do with how many rain days we had and also with temperatures and so on. Then we have recently developed a pest tool, because pests are a bit different. They could be moths or beetles that would infect an entire forest. And so we kind of looked at temperatures, and we used the products that Porrick and his team in the climate services are producing. So this is being tested at the moment. And the other animal, of course, the other plant disease is blight. And you can find these blight forecasts on our website. When you go to forecasts under and you go down, you see, in fact, the blight as well as the fire danger. So with the blight, it's kind of even the language. Sometimes you might hear someone say it's blighty weather. And that means it's kind of over 10 degrees and the relative humidity is over 88%. So it's kind of clammy, and also it's warm and mild even in the night. At the moment, actually, it's kind of like around the south coast. There is these conditions. There's no potatoes in the field, but it's this clamminess where fungal spores can grow and develop and then go from plant to plant and then from field to field, so on. And in fact, Met Éireann are instrumenting or rolling out an instrumentation network on fungal spores and pollen. So this is an automated instrument. It's quite expensive, but this is being trialed, and we have a close collaboration with Teagasc, Oak Park, and the crop experts, as well as DCU. And so we are testing things. So the pollen is to do with human health, and then the fungal spores, we're looking at validating our blight forecasts, and then also going possibly into oat diseases and so on. So this is really to do with fungal things like mild and humid and a bit of rain. It doesn't have to have a lot of rain. It's just like a bit of humidity. And then LOD next, we'll talk more about the plant growth. We provide LOD and Teagasc with our observations as well as forecast. So then she can run the detailed grass growth models. And I mentioned already forest fires, and you might not think that forest fires is a big deal, but it is in Ireland, because you may not see the forest fires, but as soon as we don't have our maritime airstream from the Atlantic, if we have, say, wind from the east or from the northeast, so the air comes from Scandinavia or the continent, and that air is continental and much drier, and then small twigs in bushes dry out very, very quickly, and then we have a very high forest danger. We had that incident on the 10th of July this year in the middle of the harvesting season. So then it becomes quite important that people are very vigilant. And also it was at the same time we had a hot weather warning, so people are out having barbecues, just to be very, very careful, because if you leave something, it can start a fire. And then, if it's in the urban forest interface, and it can then spread into forests. So that's the forest fires. And then I go on to dispersion. So dispersion is has lots of aspects. It basically, if something is carried by the wind, that could be midgets or mosquitoes, and these mosquitoes could potentially carry disease. And we monitor those, and like if something happens in the UK or northern France, and these mosquitoes can be carried that distance. And if they do have the disease and if they do land on animals, then they could get infected. So we look at the areas of risk for infections. Yeah, so it just gives you like an idea of all the aspects, and then the soil moisture, as Porrick kind of like mentioned as well, and the evapotranspiration, and so on and so on. There's lots more to talk about.
There's so much, Clara, so much. And can I just say that Closh and Fearshik and Glanmire have given you a personal shout out. They said a big hello to Dr. Finkela. So you must have a contact there who knows you well. So yes, a big shout out to them. So thank you so much, Clara. Yes, I think we've only scratched the surface of all of the various aspects that you and your role in Met Éireann cover. So as you mentioned, we're going to have Elodie next, but as we're just waiting for Elodie to join on her video, I wanted to give a huge shout out to just some of the schools who've put in their school into the chat. So a big hello to CBC in Monkstown. So huge hello to you. I love to see some primary school students have joined us, and all the way from Dunmore National School, the 6th class. So a big hello to you guys. Kilkenny, which is where I'm from originally. I'm delighted to see that we have CBC in Kilkenny have also joined us. And in this round, last one that I'll call out is Presentation College, Headford in County Galway. So you're all so welcome today. So keep those coming in. We will shout out as many of you guys as we can. Over to you, Elodie.
Hi everyone, my name is Elodie Ruel and I'm a research officer with Teagasc Ireland Agriculture and Food Development Authority. In my job, I work on something called grass growth prediction models. That might sound a bit technical, but really it's about using science and computer models to figure out how grass grows under different conditions, like changing in weather, soil, or farming practice. You might be wondering, why does grass matter so much? Well, in Ireland, grass is the main food for cows and sheep. If farmers can predict how much grass will grow, they can plan better, making sure animals have enough to eat, reducing waste, and even helping out to cut down on greenhouse gases emission. So this research is important for farming, for the environment, and for producing food in a sustainable way. In the webinar, I will be sharing more about how we use data and models to make this prediction, why it's exciting to work at the edge of science and farming, and how this kind of research can shape the future of agriculture. Hi everyone. So my name, as I said, is Elodie Ruel, and I want to talk a bit about grass today. But before I do that, just a bit of background about myself, because I guess when I was your age, what I really liked was three main things. It was tennis, video games, and anything related to animals. And I do guess I haven't changed that much, because I'm still playing really a lot of tennis. And my work is really like, almost a video game. It's creating model to try to answer question. It's almost a bit like, I don't know, farming simulator, but for real, as I said. So what about grass? So as I said in the video, why are we interested into grass or grass growth and grass growth prediction? Well, because all the cows in this country eat mainly grass. And they actually eat a lot of it every day. So they eat around 100 kilograms of grass per day. So that's, a fairly big amount. So farmer needs to know how much grass they have on their farm to make sure that they have enough food for their animal. But if you think about it, and maybe you haven't realized it, but you actually do know it, grass growth doesn't grow the same at every time of the year. So if you think about when you have to cut the lawn, for example, in your garden, well, there's time maybe at the end of the spring, start of the summer, you have to cut your lawn every week almost to keep the grass at the same height. And when you arrive during this period, you might not cut your lawn again until February. So that's what really shows a variation in grass growth. And why is that happening? Well, it's really because grass really like three things. Grass like sun, grass like some specific temperature, we'll say around 10 and 18 degrees in average temperature for the day is what Irish grasshoppers prefer. and they like a bit of rain. So basically what happened at time like today, I don't know if it's like here, you look outside, there is literally no sun. So that's really reducing grass growth. Also, it's starting to be a bit cold, so those two things will reduce the grass growth potential and how much grass can grow today. Then if you think a small bit and you go, I don't know, around April and so on, well, days are getting longer, temperatures are getting warmer, and so that means that grass can grow a small bit more. So that's literally what happened. You know, it's all really much weather related. Now, if you think a small bit in the summer, around July, August, sometimes you don't have to cut your lawn every week anymore. And sometimes even doesn't happen that often in Ireland, in fairness, but the grass might start to turn yellow. And often that's due to lack of water. So there isn't enough rainfall. So the ground is getting very dry. The grass is not getting enough water, and so it's slowing down the growth. Now, while I say that grass do like rainfall, too much rainfall like today isn't great either. So once again, if you think, I don't know, I'm sure lots of you play GAA, and if you think that you're gonna, I don't know, play a match this weekend and the ground is saturated, it's really wet, you know, and you all go and run on it, probably the field won't look very good after that because it's too wet. Well, imagine if you do that with a big herd of cows going outside on them. Well, you will just have mud at the end of the day. So, and that's really a problem because that means that literally you have no more grass, so it won't be able to grow again to feed the cow in few months or something. So farmers need to be very careful on the weather condition and where they put their cows depending on the weather. If I finish a small bit about what I'm doing, so basically all the information I gave you there in how grass is growing and what is impacting grass growth, I put that in a model I have created. So it's literally a lot of equation, all in the computer, and which allow to take into account weather, soil type also, and farmer management to be able to predict grass growth for the coming week. So the weather is coming from Met Éireann. And another small thing I actually need is to know how much nitrogen fertilizer farmers have put on their field. Because nitrogen is really the feed of the grass. And so if there is no nitrogen, the grass will grow way slower. So that's all for me, Eimear. Back to you.
Wow, amazing, Elodie. Again, who knew there was so much science behind grass growth? It's just fascinating. So again, while we're getting ready for Carl to join us, another few shout outs here. So I'm delighted to see that the first year climate action class in Naas Community College, County Kildare are joining us. So again, this is really appropriate for you guys. And that the second year class from Tarbert Comprehensive School in Kerry are joining us as well today. So again, amazing, amazing to see so many of you joining in. It is absolutely milling down here. I'm so glad you can't hear my microphone too loud. Okay, over to you, Carl, to finish us out on our presentations.
Hello everyone, my name is Carl Richards and I'm head of the Teagasc Climate Centre. I'm really looking forward to talking to you about agriculture and what we're doing to combat climate change and how science is leading the way. At Teagasc, we're working with and for farmers to tackle this challenge head on, from reducing emissions and improving soil health to protecting biodiversity and finding practical, science-based solutions for a sustainable future. In today's talk, I'll share some exciting research we're doing, including how we're using technology to measure cow burps and how we manage those cows, and also how we're measuring greenhouse gas emissions from the soil under our feet. These are just two exciting examples of innovative projects showing real promise right now to reduce greenhouse gas emissions from farming. It's exciting, it's meaningful, and it's happening right here in Ireland. So when you think about climate change, remember, the science we're doing today is shaping the solutions for tomorrow. And I believe it's your generation that will make it happen. Good morning, everybody, and it's really great to be live with you now. So you've just seen a snapshot of what we're doing here in the Teagasc Climate Centre. But before I show you some of our research, let's make sure we all understand what we mean by greenhouse gases, or GHGs as we call them sometimes for short. You've already heard from Pádraig about CO2, and that is one of our greenhouse gases. But these greenhouse gases, in simple terms, they trap air and trap heat. It's a bit like a blanket wrapped around the earth, keeping the heat in. And while we need some of these gases to keep our planet warm enough to live on, when there's too much, it makes our planet heat up, and that's what causes climate change. The main greenhouse gases are carbon dioxide, which Porrick mentioned, but also methane and nitrous oxide. Nitrous oxide is also known as laughing gas, but in farming, it's not really a laughing matter. So within the Climate Centre, our focus is really on CO2, but also on methane and nitrous oxide. So where do these gases come from? Well, methane comes from animals, and it's what's really important. It's a natural process. Porrick or Elodie mentioned cows eat 100 kilograms of grass per day. That grass contains about 45 kilograms of carbon or 165 kilograms of CO2. So that's trapped from the air into the grass. But when the cows eat that grass, which is something that we can't eat as humans. Grass isn't particularly tasty, and we're not able to digest it. But cows have a special stomach that breaks the grass down, and they can eat it. So when they do that, the carbon in the grass produces a small amount of a gas called methane, which is a really potent greenhouse gas. It's 26 times more powerful than carbon dioxide on its own. And they release this through burping. You might have heard about cow farts, but it's really through burping that they release most of that methane. And this greenhouse gas, it's part of how cows turn grass into milk and meat and the foods that are essential for us. In Ireland, most of our cows are grass-fed, which means they spend much of the year outside eating fresh grass. Grass-fed farming suits Ireland's mild, wet climate that you've heard colleagues of Porrick, Aoife and Clara speaking about. But it also helps to maintain our green landscapes and part of our green image. But it still produces methane. So our challenge is to make it as climate friendly as possible. Another source of emissions is fertilizer. When farmers spread this on fields to grow their grass and crops, it can release small amounts of nitrous oxide, which is the third greenhouse gas. And it's even more powerful than methane. It's somewhere around 290 times more powerful than CO2 itself. And therefore, a small amount of that gas can have a really big impact. This gas is made by tiny bacteria in the soil and fungi, which break down some of that nitrogen fertilizer as part of their life processes. When the soil is wet or when there's more fertilizer than the crops or grass can use, these bacteria can release small amounts of this laughing gas, nitrous oxide. So even though it's a natural process, it's one that we can manage better by using the right type of fertilizer, the right amount of fertilizer in the right place at the right time to meet grass and crop needs. So what do we actually do and what do we look at? So some of our cool experiments that I mentioned in the video, the first one here you see on the slide, the machine on the bottom left, this is called the green feed. And it's really like a cow breathalyzer. It measures when the cow sticks its head in to eat a small amount of food that we give it in the machine measures how much methane it breathes out. It also measures CO2 and other things as well. By using this, we can test out how we can change the cow's diet, how we can improve the cow's genetics, and how we can add all other things into the cow feeds to reduce methane. Sometimes even small changes can make a big difference. The second picture on the bottom right shows an auto chamber that is closing and opening. When it closes, it measures greenhouse gases coming from the soil. And this helps us to better understand how much nitrous oxide is released after fertilizer is spread on soil or after rain. And we're testing things like different types of fertilizers and more efficient fertilizers, how using less fertilizer and how improving things like the health of our soils can grow the same amount of grass or the same amount of crops, but with lower emissions. So we're doing experiments on farms and in the labs to find real life solutions, things that farmers can actually use now. It's science in action and it's helping Irish farmers become more climate friendly. So what's really exciting in this research, it's happening right here in Ireland. It's not in a far off country, in a far off lab, and it's helping our farmers to make positive changes. Science is giving us the tools, but your generation will be the one that takes these on and builds upon them. So to wrap up now, so the next time you see a cow or a bag of fertilizer, think of the science that's behind it, because what we learn today can help protect the planet tomorrow.
Amazing, Carla. I love that's what a fantastic way to finish out our presentation part of today. Yeah, it's up to you guys. It's handing over the baton. We definitely are working very, very hard across both our organizations to provide the evidence, provide the science. But again, we're always looking into the future, and you guys are the future. So while I'm waiting for my panelists to come back in, I have seen some questions coming in. So I'm delighted, and I hope now we've given you some food for thought across all of our presentations so far this morning. So I'm going to start, Aoife, if that's okay with you. We've had a question here from Ardskull Reese in Marino in Dublin. So big shout out to you guys and thank you for your question. And they are asking a really practical question, which is how long does it take to become a qualified meteorologist? Over to you, Aoife.
Brilliant question. Yes, so the first thing you want to do if you want to become a meteorologist is complete a degree in either maths, physics, meteorology, or even some people have degrees in astrophysics. So anything that gives you that background in physics or maths or meteorology as well, of course, will be fantastic. So those degrees usually take about 4 years. But even once you've done that, if you want to become an operational meteorologist, so a weather forecaster, you will then have to go on and do on-the-job training. So I myself trained in KNMI in the Netherlands. So that took about 6 months. And then I was shadowing for another 6 months. So all in all, probably if you put it together, about 5 years. But you're always learning on the job. So, you know, it's great. You're always learning something new.
I love that. Isn't that the dream? And it's what I love about my job as well in science communications is every day is a school day. So yeah, some of you sitting in school today, just think into the future. If you can land yourself a lovely job in science like we have around the table here, you're always learning something new, which is so exciting. Elodie, I'm going to come to you next. So a question is coming in here, which is asking, why do farmers spread fertilizer? Can't grass just grow on its own? Over to you, Elodie.
Yeah, so if farmer wouldn't put any fertilizer, grass will probably grow, but way slower. So you wouldn't have that much grass to feed their animal in the spring and the summer and so on. So really, for them, you know, in your garden, you don't need to spread fertilizer because you actually don't want your grass to grow that fast. Otherwise, instead of cutting your lawn every week, you might have to do it every 3 days, which wouldn't be great news for you. But to feed the animal and to be able to have enough feed for all their cows, they need to put fertilizer.
Fantastic answer. Really, really good. Okay, I'm coming to you next, Warwick. Okay, so do you think our weather will get wetter in the future? And this is from Cian from Kinsale Community School. Over to you, Warwick.
Thank you very much. Yeah, it's a great question based on how wet it is today. But so it depends is the answer. It depends on what season that you're looking at. So we know that when the atmosphere gets warmer, it can hold more moisture. So for every 1 degree of warming, we get about 7% more moisture in the atmosphere. So that means that moisture has to go somewhere and it has to fall out of the atmosphere and it falls out as rain. So when it does rain, it is already raining heavier. And that is because of climate change. So when the rain falls, it falls more. And we know that from our climate change projections, when we look into the future, depending on how much warming we are going to get, we're going to get wetter. So the more warming that we have, the wetter we're going to get as well, which means it's going to rain more. But this doesn't mean it's going to be wet all the time. So in summer, we're going to see changes in rainfall that could lead to decreases in rainfall and increased drought periods as well. And then when rain does fall, it'll be falling onto drier soils, which will mean an increased risk of flooding. It won't get into the soil, grass won't grow properly. So summer rainfall might go down. It's looking like it's going to go down depending on how much more warmer that we get. And then in other seasons, winter rainfall is going to increase, autumn rainfall increasing as well. So overall, we're going to get wetter. It's going to be a change in rainfall patterns, but in summer we could see a decline in rainfall patterns.
Okay, another fantastic answer. So thank you so much to Cian there in Kinsale Community College. Carl, over to you next. So we've got another question coming here, which is what percentage of greenhouse gases actually come from cows each year, based on the evidence?
Yeah, really, really good question. So in Ireland, cows or agriculture accounts for just under 40% of our national emissions. And of that, methane is about 28%, and nitrous oxide is maybe 11-ish% of that.
Okay, fascinating. Okay. If I was to ask you, Clara, just a question regarding your career. So again, the breadth and depth of all of the different things that you touch on, whether it's meteorology and agriculture and the implications there, what made you want to become a meteorologist? And can you tell us a little bit about your background, your career?
Um, I come from a small farm in Bavaria, in Germany, in the south of Germany, and I find clouds fascinating. So as a small kid, I would always look at the clouds. And so when I was in school, I kind of was very good at mathematics. And then I endeavored to actually study mathematics, even so I kind of thought, this is really for people who are geniuses, and I'm not a genius, I'm just ordinary. But then I actually really loved it, mathematics. And then I started a PhD in mathematics, but I wanted to do something applied. I wanted to do, sort of, when you're young and enthusiastic and you want to solve the world's problems or do something useful. And the mathematics was a bit too technical, too dry. So I switched to meteorology and I did my PhD in Australia. And that was fascinating. And I still like looking at clouds. But what is really the most important aspect in science, in agricultural meteorology, is a mathematical understanding and like physics. Everything happens at the soil, plant, atmosphere interface. So like what Carl talked about, what Porrick talked about, what Elodie talked about, it's all about, how the soil moisture, like the rain falls on the land, it gets into the soil, it transpires into the atmosphere, and then the whole cycle. So to have a physical understanding, to have a mathematical understanding, that's the most
Yeah,
important.
is the most important. So looking out to our audience here today. So keep maths in your mind, the application of maths as well. I know sometimes when you're in the middle of those really difficult maths, complicated solutions, sometimes you kind of can forget, what the context is. So just the use of maths and how maths can really solve the world's problems. So Elodie, I'm coming back to you for our next question, which is a very specific one, which is how much grass do sheep consume each day? You spoke about cows and sheep. What way do they go? If we're talking about 100 kgs for cows, are sheep on a par, or what do we think?
I'm gonna sound very bad, but I actually don't know that because my
Good
specialty would be
question.
more on cows. Maybe
Yeah,
Carl can come in, maybe he knows more than me, but like, yeah, I actually don't know.
I know I used to have a really big cool fact, which is about us being outnumbered by sheep in Ireland at one point in time, but I think we've caught up with them in terms of population size. Carol, do sheep have a big impact?
No, because they're generally quite small animals. I was
Mm.
just trying to look up how much a sheep eats, but I couldn't. You beat me to it. But generally, no. Look, they're small. They're smaller animals. We do have a lot of them. But unfortunately, with greenhouse gases, every little bit counts. So even though sheep are small and they use less nitrogen on sheep farms and they consume less, they still produce some greenhouse gases.
Mm.
And our targets for Ireland are to reduce our agricultural greenhouse gases by 25% by 2030. And that's only, what, 5 years away. So
Mhm.
we need to really, I suppose, increase our climate action on farms.
Definitely a big challenge, absolutely. To Aoife, I'm coming back to you again. So, how do you make sure storms all have unique names? And this is from Elaine from Mount Anvil. So, a huge shout out to Mount Anvil who are now checking in. So, tell us a little bit more about that naming. How do we make sure they're unique?
Yes, so we name storms basically in conjunction with the UKMO, so the Met Office in the UK, and those in the Netherlands as well. So the guys that I trained up with originally. And what we do every year is people from all those organizations get together and they compile the list of names. So you might have seen the list of names for this year. So we already had Storm Amy. So those names are all chosen before we get to the kind of new storm, storm season we call it, but really it just runs from September to September. So when it comes around to having to name a storm as a forecaster, all we have to do is go to the list and choose the next one alphabetically. So if there was a storm in the next few weeks and I was on duty, all I'd have to do is go to the list and choose the name Bram. And that's how I'd name the storm. And they make sure whenever they're choosing these lists of names, they make sure that they're not using a name that has been used before.
It's really cool. No, definitely. I always love seeing the names being announced for the year ahead, albeit that they are a storm coming. So it's, as you said, that awareness piece is so important when it comes to meteorology. And I think you guys in Met Éireann are doing such a fantastic job in bringing people's awareness, both from a safety and from a practical side of things. So my next question is for Carl. So I'm not too sure who this came in from, but it's a good one. What's the coolest experiment you've done on a farm?
Good, super question, and I suppose honest answer is I've done loads of cool experiments on farms. The one that probably had the biggest impact, so the one that I'm most proud of, is probably where we looked at different fertilizer types to see how much nitrous oxide they emitted. And from that research, we basically found that the most common fertilizer used in Ireland, which is a product called calcium ammonium nitrate, had emissions that were 50% higher than the international average. But we also looked at what we call protected urea, which is a different type of fertilizer, and it had emissions that were 60% lower than that. So from that, we developed our recommendation for farmers to switch from the really high emitting fertilizer to a really efficient low emitting fertilizer. And I suppose one of the really cool things as well is farmers doing that actually save money too, because it's a slightly cheaper type of fertilizer.
A win-win. Absolutely. That is a really cool experiment because it is, of course, Science Week. So for those of you in the classrooms joining in from all over the country, just remember the impact of these experiments. These are asking questions, they're making observations, and they're making real impact. So well done. That's a great answer, Carol. Next one is for you, Clara. So we've got a question about what you were talking about with forest fires. So the question that has come in is, what percentage of forest fires are actually caused by climate change each year?
I wouldn't know the answer to Ireland, but they just released a report for globally what fires are caused by climate change. So it's an attribution study. So you can actually go and look at those reports. I mean, for Ireland, I wouldn't know, because for us, it's really when we have, as I said, these easterlies. But what the trends are showing is that our fires get bigger and more complex. Like a couple of years ago, there was a fire in the Mournes Mountains that was attended by Northern Ireland Fire Services as well as the Republic. And it was like multi-agencies and for like 30, 40 days. And it's like massive. So they become bigger and more complex, also with higher winds. And so the whole climate change is really driving bigger and more dangerous, really.
Absolutely. There's just so many facets to consider, and like that, it's hard to tease out how much is climate change and how much is attributed to each part. So yeah, really, really cool. Thanks, Clara. Porrick, if I'm just coming to you, I'm just going to ask you the same question that we got for Carl there because I found that a really nice answer. What was the coolest experiment you've ever done?
Oh, well, so I am a really boring nerd who doesn't do exciting experiments. I sit at a computer and analyze data all day long. So I've never really done a huge amount of field work. But the thing that comes to mind recently is about Clara's soil moisture network, where we went out and we sampled, we went down to a field in Tullamore. And it was one of the few times in my life where I've actually done some real hands-on science, where I got to dig holes and we got to take soil samples. And we did this for a whole field, and then those soil samples get dried out, and we can see how much moisture is in the soil, and then we can use that to kind of calibrate and assess instrumentation and see how good the instrument actually is at measuring the soil moisture. But for day-to-day stuff, all I do is look at numbers on a computer. So I'm really sorry, I'm really boring.
That's okay because do you know what? It's one of my bugbears that all experiments are different. They look very different. Some of us, and actually most of us, the people I work with, don't wear lab coats either. So for those of you tuning in thinking all scientists wear lab coats, no, we do not. Some of us are based on computers. I'm looking at Elodie here, and yes, I loved how Elodie called on the fact that she loved computer programming, loved gaming when she was growing up. So I think that's really cool that she gets to do that each and every day. So thank you, Porrick. Believe it, Porrick, I have another question after coming in for you, so no rest for you there for 2 minutes. So, Porrick, climate is always changing. How do we know that it's humans that are doing it?
Oh yeah, that's a very good question. So, like there's two kind of elements of climate change. There's natural climate change, which happens over a much longer period of time. The Earth goes in and out of ice ages. The Earth's orbit changes, When we're further away from the sun, we get cooler, and then the planet can be covered in ice like we have during ice ages. But what's different between that and the climate change we're experiencing now is the rate of change. So the absolute speed of temperature increase now is beyond anything that we've observed before since humans have been on the planet, and since long before that as well. So it's that rate of change, and how we know it's happening. We can run climate models, so like our weather forecast models, but just for much longer periods of time. And we can run those models with greenhouse gases from before the Industrial Revolution. So we can imagine if we never burned a fossil fuel, we never took oil out of the ground, what would the climate be like? And it turns out that the climate would be very similar. It would not have changed much at all. We'd actually be slightly cooler if we were just going on natural cycles. But then when we add the greenhouse gases that come from all of our burning fossil fuels, from the methane from the animals, from the nitrous oxide, from all those greenhouse gases, when we add them in, we can see that the climate warms, and it warms alongside our observations. So we can use these really kind of complex computer models to identify what exactly is causing climate change. And we know from that it's the burning of greenhouse gases or the burning of fossil fuels, the release of greenhouse gases that's causing the climate change that we see now.
Wow. Amazing. Absolutely amazing. Few shout outs where we're just waiting for a few more questions to come in there. We're delighted to be joined from St. Al's in Cork City. I used to walk past that school each and every day when I lived up in Cork City. Transitioners from Mount Anville Secondary School. I think I already gave you a sneaky little shout out already, but another one just to add to that there. Newbridge, County Kildare. We are joined by Holy Family Secondary School in Newbridge, County Kildare. You are so welcome. Hello from COI. Acronyms. We're divils for that in science anyway, so I'm not too sure who that school is, but you're very welcome. You know who you are, COI. Hello from the first years in Coláiste, and it says IA. So again, that could be another acronym there, but thank you for joining in. And only up the road, I'm here in North Cork, but just to say a big hello from the first years in 1E in Coláiste in Cahir, County Tipperary. So again, just very, very close to us here in Moore Park, County Cork. So we've only a couple of minutes left. I'm just looking to see to my moderators who are very shy. They haven't got their cameras on, which is okay. But Grania, Warren and Rebecca have been doing a fantastic job going through your questions. I'm just going to see, is there any last ones here? Okay, I'm going to ask a question just off the top of my head, which is to Elodie. Elodie, we've spoken about a lot of people's careers and different things like that. How does one become a scientist based in Teagasc from France? Tell us a little bit more. What got you into this space?
So it's an interesting story. It wasn't my plan at all. While working with computer was probably my plan, well, not even. So when I was younger, I really wanted to be a vet, but being a vet in France, and I'm fairly sure it's very similar in Ireland, is very hard. And actually, to be a vet in France, you need to be very good at languages, like English and German, for example. Now my English is fairly good now, but it wasn't when I was younger. So I tried to become a vet, but basically I was very good in maths and very bad in German, so I couldn't. So I did end up in some university around agrology and cows and so on. So that's because it was the closest enough to vet in my head at that minute. And then I discovered there was something which was called modeling biological system. So that's what I did as a degree. And I did an internship in RAI, which is the equivalent of Teagasc, but in France. And really, how I arrived here was a bit of luck. Of one day in a meeting, one of the researchers said, who wants to do a PhD in Teagasc, where the PhD would be to recreate a whole farm on a computer? And I was like, that sounds very much like exactly I want to do. So I just say, yes, I know me. And I arrived here.
Amazing. I love that.
And my plan was to stay for 3 years, but 14 years after, I'm still here. So you never know. You just never know what happens.
Just never know. You just never know. And I loved how, Clara, you even spoke about the amount of travel that you've done. You've lived in Australia, you've lived in obviously Germany and now in Ireland. And I think one thing that always for me resonates is the fact that science is like a passport for the world, because the scientists that I work with, and including myself from my own background, I get to go to conferences all across the world, and it's just amazing. So my friends, we are drawing to a close now. So I just want to make note of a question that came in there about the recording. So yes, this is being recorded and we will make this available afterwards. So for the teachers who registered in advance, you will get a link to this recording afterwards. And we'll also make it available on YouTube so that you can watch it back and maybe use it in your case studies. So This gives me the ultimate pleasure to say a huge thank you to each and every one of our panelists for joining us today. I think, Elodie, I have one final slide, which is just a huge big thank you. And also just to say to people, happy Science Week. I know all of the scientists around the table here are very happy and proud to be scientists. And if you are in your classroom and if your school allows, we would love to see the names and faces of people who are joining us today. So please do, if you're on social media, in your school or in your home, please give us a shout out by using the hashtag Science Week and Clouds, Crops and Climate. So thank you so much to everybody today. Fantastic questions. We will talk to you all again soon. Bye.